Is the exam on? Well, I'm giving you a cheat sheet, right? And that cheat sheet has a lot of the things that's on this page, especially all these equations, right? So what types of, Sydney, let's see if you can remember this. If I take a look at one of these equations, like this one, what could be a question that you could make up that you'd have to use this equation? What could be something they'd ask you?
They wanted to know like how many grams reacted or something.
Ooh. Okay, if they, like how many grams of something reacted, then they're going to have to give you a reaction. Now that's going to be a complicated one, right? They're going to give you, and something in here has to be a gas, right? She's talking about how many grams of something reacted. Well, if that's going to be the question, and you have to use this equation, there has to be a chemical reaction, so you do the mole bridge, and a gas, and they got to give you a pressure, volume, right? I wasn't expecting her to ask that. I was expecting her to say something like, okay, what's the volume of a gas if this is its pressure, and that's the number of moles, and that's the temperature, right? That's kind of what I was thinking. And, right, because there's only this 4 unknowns. They're going to give you 3 of them, okay? But yeah, those equation ones, I have to make sure we review that one too. Okay, how about same story, but this equation? Mia, when would you use something like this much larger equation? It has 6 variables in it. Has 2 what? 2 moles. Moles isn't even in the equation. This is where they're changing what? They could be changing what? Temperature? Ask for the new temperature. They could be changing volume, asking for the new volume. They could be changing pressure, asking you for the new pressure, right? And you can't do that with this equation because you can't be changing pressure, volume, or temperature because there's only one of them. So if you're changing pressure, asking for a new pressure, asking for a new volume, asking for a new temperature, yeah, this is the equation that we're going to be using when those things are changing. Okay, I think then we jump down to something like that. So Megan, with this PM equals dirt equation, they could ask us for something, and then, oh, you just jump right to this equation. What would they ask you for? Molar mass, big M, right? And I think the trick to using this was to know the units to plug in for little d. I think that was the trick. Bowdy, what was the trick that, because molar mass is, grams per mole, you just get it from the periodic table. But what was little d, and what units did it have to be in?
I know it, but I can't because it was like, I don't know.
Does anyone remember? Grams per liter. It was the D word. It was density. It was density, and had to be in grams per liter. Okay, so throughout this equation and through both of these, it has big R in it. What'd you use for big R, Dylan? And the 0.0821 was a lot easier to use, right? I agree with him. This one is a lot easier to use. Why is that the one that we've been using all this time, Paul? Why is that the R that Dylan's right? Why are we always using that one? Because the units, exactly. It tells you what all the units got to be. Pressure in atmospheres, volume in liters, Little n in moles. Temperature in Kelvin. Temperature's always in Kelvin, but okay. And then we got off of gases, and we started doing this Q stuff. Is that the same Q? Tanya, is that the same little Q? Yeah, so there's two ways to get this little Q. A more layman's term, Emily, for Q was what? Enthalpy or heat. Yep. Okay. So there are two ways to do it. Okay. Alyssa, here's a good question. See, I don't think it really mattered whether you remembered this or not, but I think it helps. What were these called? C and S. C was heat capacity. Because if you remember that, it really will help you pick the right equation, right? Ooh, she remembers both of them. Specific heat. So if you remember both of those, it'll really help you. But you don't need to if you're comfortable with them, because these guys will be giving in units, whether you know the name of it or not. Like this one will be in so many joules per degree Celsius. This one, specific heat, very similar, joules per degree Celsius, but it also has a mass unit in it, like grams or something, times grams. So both Celsius and grams are in the bottom. Okay. So, and you have to cancel out those units to get your heat in joules. Right? Because our heat was energy, that always had to be joules. Okay. Oh, we moved off of gases too quick because we used this. A table of vapor pressure of water. Steph, when did we have to use a table of vapor pressure of water? No. You're collecting a gas over water. Exactly. That's when you had to use this. You were collecting a gas over water. And this is pretty much, I think, where we started out with Sydney's question. Right? She might have been thinking about this. There's a reaction, and you're collecting this gas over water. Okay, Lorena. What's the big whoopee-hoo? What did you use this table for? Let's go back. Let's go do the big picture. PV equals nRT. You're going to collect a gas over water, and you're going to use this equation. So you're really after N, so you can convert, right, the moles of the gas to whatever they want. All right? You have to use the mole bridge to get there. So the whole big goal of this was to get little n. So then you'd know what the moles of the gas are. Then you use the mole bridge. Use the mole bridge to get what you want. I don't know, grams of iron or something. Who knows? Whatever they want, you have to use the mole bridge. But that starts with knowing what the moles of gas are. Then use the mole bridge to get the grams, whatever you want in that chemical reaction. And we had to use PV equals nRT to do it. But how, Lorena, did this table fit in? Didn't have anything to do with the temperature. Does anyone remember? Find the right pressure. Exactly. This P, whenever you collect a gas over water, that P was always, who can finish the sentence? Always too high. It was always too high. That P is always too high. If you plug in the pressure that they give you, you're going to get an answer that's way too big because the pressure is way too high. Because the pressure isn't due just to that gas that you're trying to collect. It's also due to water. So you got to subtract it out. So you find the temperature that they're messing with and subtract out the right pressure. Right? That's at 30, well then you'd subtract out 31.8, but look at those funky units. Millimeters of mercury, so you got to be careful, right? Make sure you might have to do some converting there. But always subtract out the pressure due to water when you're collecting a gas over water. So that was the game plan for doing that. Then solve for little n, then use mole bridge, and you'll have your answers. Quantum numbers, it pretty much just came down, that's why the quiz was just the table. Because man, if you know the table we discussed in class, anything that's asked, you can answer. Okay, but just be really familiar with that table that you just took a quiz on. Okay, so I say we just start at the beginning and see how far we can get, and then what we don't get done, we can wrap up at the help session, or you can come in and ask some questions. So how would you like to do these? Would you like to work on these in groups or at the boards, or let it be the democratic process? What do you want to do? Giselle, what do you want to work? How do you want to do this? In groups. Okay. So let's just have the front row turn around and work with the people behind you. All right? So there's your group. Front row, turn around, work with the folks here. You guys turn around, work with the folks right there. Make sense? So there's your group. And then if you have a question on it, just ask, and I'll be glad to work it out. Any ideas on 52? If you use PV equals nRT, then I think you're assuming what are you going to use for your n? To me, that's the problem. What would n be if you use that one? You'd have to find the moles. That means you'd have to know grams or something. Is this nitrogen? That's just sample. So that's information that problems that give you extra stuff are always much more complicated. So PV equals nRT is not going to get you where you need to go. It's not going to work. Kenneth, another one. How about what?
Would this one work for? PV over T.
Yeah, the big one. All right. Notice how, for me, the hint is, see how they give you multiple temperatures, multiple pressures, like Kenneth was saying? So it kind of leads you as to which one you got to use. Yeah. Multiple pressures, multiple temperatures. Find the new volume. And do you remember what temperature had to be in? It had to be in Kelvin, yes. Otherwise, everything gets thrown off. The other units just had to be consistent.
So only the heat problems are in Celsius, and the rest are in Kelvin for temperature.
Yes, that's very true. Those heat problems are always in Celsius, right? Because they always give you C and little s. They're always in per Celsius. I've never seen them in per Kelvin. Mm-hmm. I think as long as if V1 is in milliliters, V2 will be in milliliters. It'll be just have to be consistent. Did you get an answer, Kenneth?
First one.
For the first one?
Oh, first one? It's got 0.003. Well, when I got it, it was 3.
For the new volume?
5.
Liters or milliliters?
Milliliters. Wait, no, I put it in liters, so this should be liters. Because I changed it to liters.
Oh, okay.
That's why it's all the way.
So 3.65 times -3 liters or 3.65 times 3 milliliters? Did anybody get an answer for this?
3.6.
Yeah. 3.65 milliliters or 3.65 times 10 to the -3 liters, right? That's what Kenneth got. Okay, good. So you should get one of these. Then you can move on.
What's that? Okay, this thing gives you volume, pressure, and temperature, but that's molecular mass of a solid. So I don't know what
I feel like Sarah said she's got the cheat sheet torn out. This is what you should do. right? Just look at this. They're asking for molar mass, so that's the big hint.
So would that just be the big M one then? 'Cause-
There you go.
Okay. Then I could already write this.
Solve for big M.
I know, but we're missing D. We have to
Okay, good. Now what do the units of D have to be?
grams over liter.
There you go. So you just got to find it.
That over that.
But this is in
I know,
the-
you gotta transfer.
There you go.
Yeah.
You got it. So 70 seems like it's straightforward what equation to use, but how to apply it isn't so straightforward. What equation? Yes, PM equals dirt, because it has big M in it.
And since it's in like the MMHG, we can leave it like that? That's okay? Or do we have to convert it to the ATM?
Everything's determined, but whenever you have big R, everything's determined by big R. All the units are.
Okay. Since they gave me grams here and then they gave me milliliters here, I just divide the grams by the milliliters after trying to get the liters.
You should put your units everywhere, though. Otherwise, it gets really confusing.
Like I have it, like yeah, just fine. Like, I have it under it, so R is just that, T is this. and
Yeah.
T is that.
Yeah, it's just, it's, because you're going to end up losing points. You're going to forget to put units on your final answer.
Oh, I always put units, but it's like I never put units on these setup.
All right. I'm just telling you, it'll help you in the long run.
Divide it, you get 1.296. You can just leave it at 1.3.
Do you have to turn the pressure into ATMs though?
Yeah.
Because you do?
Yeah,
Well, yeah, I got it.
What'd you get as an answer?
2.3?
Say 1.3.
0.23.
Yeah, I did it right. Unless
Yeah, you can't have a molar mass of 0.23, though.
I didn't convert that. Am I supposed to?
Oh. Whenever you have the gas constant R in your equation, you have to, everything has to be in the units that big R is in. You have no choice. So realize, yeah, whenever on our cheat sheet we have all these equations, if you're going to pick one with the gas constant R in it, all units of everything have to be consistent. They have to be the units of what big R is. So volume has to be liters. Pressure has to be atmospheres. Temperature, Kelvin. Yep. Whoop. And 421. Does anybody get an answer for this? Molar mass? 177? Sounds like a good number. Yeah. What was your question? Oh, over here.
I was asking, which one is it? You just like to get the what was it? To get the missing thing, which is you just divide 50 by the mass of
So
oxygen.
ask Sarah first. Talk to your partner, and then I'll help you out. So somewhere around 180, right? That's what I got for number 70. Did you figure it out?
Because I was asking, did we take into account the moles here? Because if not, then I would have wrote that out. But if so, then I need to put moles. Because it's asking for the what was I gonna say?
So you're starting with 50 grams of NO, right?
Then I divided it by the actual.
Well, what? Let's start up. Start back here with what equation they want to use for 78. Start with the equation. What equation do you want to use? Does anybody have an equation that they suggest using for number 78? PV equals nRT. I agree with that. Yeah. So we're going to solve for this. There's our P. I know what P is. So the question is, how do you get N? Right? N has to be what? Moles of what, though? Moles of O2. Yeah, so they only gave you NO. So you have to use mole bridge to get there. Exactly. Did you get it to work out?
I haven't finished it.
Okay.
Was it 24?
I don't know.
Yeah, I got 24.9.
24.9 liters?
24.
Okay. Yep. 24.5 about? Okay. So somewhere around 24 and a half liters or so is what folks are getting. Depends on your rounding. 24, 25. Let's try 25. Mm-hmm.
Since this was collected over water, we have to use the table operator.
Yeah. So your pressure is going to be too high, that the pressure that they measured.
You have to convert it from the PA back to ATM, and then convert it from ATM to milliliters of high pressure.
Yeah, because that's what the table's in. Exactly.
Is this the moment? The 3-step?
Yeah, they collected over water. Yep. So your P is going to be too high.
Oh.
So that this pressure, if you don't want to know these steps, what you can do is just first figure out the equation you're going to use. You're going to use that PV equals nRT, right?
Yes.
You're going to use PV equals nRT. So the P is, so it might be easier to visualize, I think. It depends on how it works for you. But how many grams of ammonium nitrate? So this is the moles of nitrogen. That's the moles of the gas, which is the nitrogen. So you're going to have to find it first and then use the mole bridge to go here. But to find the moles of the gas, you have to solve for little n. All these are given to you, except this one is messed up. Just make it smaller. Subtract out the pressure of water doing the table. Because that pressure is nitrogen and water because it's collected over water.
Oh.
So just make that P a little bit smaller, solve for the n, and then use mole bridge.
Oh, okay.
But those essentially are the steps that you're starting to write. But get an answer for EX1, Connor, and then I can write that up there.
Yeah.
Or EX1. Anybody get an answer for EX1? Just a numerical answer for this one. Oh, you guys don't have this one? Oh, it jumped down to this one. Okay, good. That's even better, because we already did the EX1. Good. Okay. Anybody get an answer for 88? Still working on it? What'd you get? For I hear 9.16. Anybody else get 9.16? So try that one. This is a good one. We have a couple answers.
Well, then you have to convert it to grams. That's the mole bridge. And then you have to do the mole bridge to get to ammonium nitrate, and then you do convert to grams. It's never makes sense.
Well, that's a long problem, isn't it?
I always carry out a lot of decimals.
Yeah? Yeah, you can dig it in there. So have a good day. I'll have this one finished, then you can check online if you want. Yep. you wanted to know.
I get 1.43 for the N.
0.143 for the N.
Yes.
Is that what you got?
Yeah, exactly.
Okay, good.
My N answer was 9 point something. 9.4, I think.
So that was moles of
N2.
N2. Whoa, whoa, I want mole bridge. There's one of them, it's 1-to-1. Right. And what's the molar mass of
I
that?
think it's like 64.
64, wow, 32 plus 4. Plus 20. Yeah, 64. So did you get like 9.15
Yeah,
grams? Oh,
perfect.
fantastic.
Thank you.
Have a good day.
Dr. Smith,
Uh-huh.
are you gonna be in your office today?